Okay, so this is Solutions Lesson 4. Really short lesson tonight. We're going to review a little bit with Table F. We're going to talk about dilute and concentrated, and we're going to work with a little bit of math and solutions. Okay, let's get started. First of all, remember that solubility is a measure of how much solute will dissolve in a certain amount of solvent, usually water, at a given temperature. Soluble means that the substance will dissolve, aka miscible. So if I say something is miscible in something else, that means it will dissolve in it. The more soluble something is, the more concentrated it can be in solution. And remember, SOLN is an abbreviation for solution. Insoluble means it will not dissolve. And another word for that would be aka immiscible. So if something is immiscible in something else, it will not dissolve. Concentration is a ratio of the amount of solute per amount of solvent. So it's a ratio of solute to solvent. Now let's talk about dilute. A dilute solution is one that has relatively small amount of solute dissolved into a relatively large amount of solvent. And this is usually called a weak solution, aka dilute. So, or to weaken the concentration of a solution. So if dilute has a small amount of solute in a large amount of solvent, then what do you think concentrated is? So concentrated, a solution that has a relatively large amount of solute dissolved in a relatively small amount of solvent. And this is called a strong solution. So you can see here by the pictures and the font size, the ratio of the solute to solvent in a dilute solution versus the ratio of solute to solvent in a concentrated solution. Most versus least concentrated using Table F. So strong versus weak. Concentration is a term that is directly related to the amount of solute dissolved. So on a Regents question, they might say most concentrated. So we're talking about a soluble compound in this case, if we're talking about Table F, and least concentrated, we would be talking about an insoluble compound. Because if something's least concentrated, it's forming a precipitate. There isn't going to be any solvent involved. If a compound doesn't dissolve, it doesn't add to the concentration of the solution, meaning it's least concentrated or insoluble, precipitate, aka solid. All right, let's look at a couple of examples. And this is what we were actually doing in class today, but we had already used Table F in a previous lesson. Silver nitrate and sodium chromate solutions are mixed together. Will a precipitate form? First question. And number 2, if so, what is the name of the precipitate? So we have a chemical equation. Here's our silver nitrate, AgNO3, plus our sodium chromate. Ag is +1, NO3 is -1, Na is +1, and chromate is -2. Remember, plus goes with minus, plus goes with minus. So the Ag hooks up with the CrO4. The Ag was +1, the Cr4 was -2. When we drop and cross, that's why this 2 comes down here. The Na hooks up with the NO3, +1, -1. Now we had to balance it. We had 2 Ag here, so we needed to put a 2 here. That's why that coefficient is there, which then gives us 2 NO3, so we came over here and put a 2 here. So remember, we're looking at remember that we're looking at the negative part of the compound. So we're going to go to CrO4 in Table F, and we can see that it forms a precipitate because Ag is not one of the exceptions. NO3, on the other hand, is a soluble compound. It has no exceptions, so this one would be aqueous. And we would mark this one, if we were writing an equation, as a solid, which means that it is a precipitate. Okay, will a precipitate form when lithium nitrate is mixed with potassium phosphate? So here's our lithium nitrate. This is +1, -1. And our potassium phosphate is going to be +1, -3. Remember, polyatomic ions come from Table E. Elements, their charges come from the periodic table. So my plus hooks up with my minus. Li is +1. We said the PO4 was -3. Drop and cross, this 3 has to come down next to the Li. And my K hooks up with my NO3. K is +1, NO3 is -1. Oops, -1. I have 3 Li here on the left, so I need to put a 3 here. That gives me 3 NO3, so I have to put a 3 here. Okay, so this equals no precipitate. Why? Well, if we look at NO3, NO3 is on the soluble side of the table, no exceptions, so this is going to be aqueous. And PO4 is on the insoluble side of the table. However, lithium meets the exception because it is a group 1 element, so this would also be aqueous. Therefore, no precipitate forms. No precipitate forms means that there is no reaction. In order for a reaction to occur, we either have to form a precipitate, a pure liquid such as water, or a gas. Okay. For the following reactions, determine the products formed and then circle any precipitate. So, silver nitrate. Silver is Ag, NO3 is minus, NO3, Ag is plus, NO3 is minus, so it's 1 to 1. Potassium chloride. Potassium is K with a +1 charge. Chloride is Cl with a -1 charge. That's 1 to 1. Remember, positive goes with negative, so Ag goes with Cl and K goes with NO3. These were all +1, -1, so I don't have to worry about anything. By now you should know nitrates are on the soluble side. No exceptions. This guy's aqueous. Chlorine is also on the soluble side, however it's mixed with silver, which is an exception, which means that it's going to be a solid. And they want us to circle our precipitate, so there we go. And the last one, copper sulfate. Oh, copper 2 sulfate. So remember that that Roman numeral tells us that we are using the +2 charge for copper. Remember, if it said copper 1, then we would be using the +1 charge. The Roman numeral tells you the actual charge. So this is going to be Cu +2. Sulfate is SO4 with a -2 charge. Sodium is Na. Hydroxide is a polyatomic ion. It's OH -1. So this is +2 -2. That's good. We don't have to drop and cross. This is +1 -1. We're good. We don't have to drop and cross. Okay. So let's start. Our plus goes with our minus. Cu is going to go with the OH minus. So Cu has a +2 charge, and OH minus has a -1 charge. So we know that we have to drop and cross. We have to put this guy in parentheses. That's 2. Sodium sulfate, the Na, is going to hook up with the SO4. So Na +1, SO4, 2 minus. I have to bring this 2 down here. So Na2SO4. Now, let's remember I have to balance my equation. I have 2 Nas on the right, so I have to make 2 here. 2 OHs, I have 2 OHs. So let's look at what's going on. SO4 sulfates are going to be soluble unless they're combined with silver, calcium, strontium, barium, or lead. Well, sodium is not one of those exceptions, so this is going to be aqueous. And then my hydroxides are insoluble. My OH is insoluble unless combined with group 1, calcium, barium, strontium, or ammonium. So this does not meet the exception. This is going to be my precipitate. So let me circle that guy. Okay. So that's a little bit more review of what we were doing in class today, and you'll get some practice with that tomorrow as well. And the last thing before we close, just a couple of calculations that I want you to be familiar with. All of these formulas can be found on Table T. Solutions are homogeneous mixtures. All solutions are homogeneous mixtures. Their compositions can vary. It is therefore important for chemists to know the composition of a solution. And we can use the following methods or formulas to specify concentrations. For example, the relative amount of salt in a solution of salt water. The higher the concentration value is, the more solute that is dissolved in solution. So, before we get started, you need to get your calculator. So the first thing that we're going to do is molarity. Molarity is, from the back of the table, molarity equals moles over liters. So just so you know what we're talking about, when we talk about moles, we're talking about moles of solute over liters of solution, which includes everything. So, in the first one, what is the molarity of a solution that contains 4 moles of NaOH in 0.5 liters? So we wrote our formula, okay? So, it says what is molarity? We don't know big M. We know that our moles are 4 moles. And we know that we have liters, 0.5 liters. Okay, write our formula, write down what we have, substitute in, molarity equals 4 divided by 0.5. So 4 divided by 0.5 is 8. So this is a molarity equal to 8. Okay, and that's moles per liter. Okay, so parts per million, ppm, is equal to your grams of solute over your grams of solution times a million, or 10 to the 6. This is often used for making very small, for very small concentrations. For example, if you want to get the water in your pool tested for chlorine, or if you want to get your drinking water tested, it's usually measured in parts per million. So we have our solute is 0.0043 grams, and our solution is 100 milliliters. And remember that 1 milliliter equals 1 gram. So this is really 100 grams. And the 20 degrees we don't need. Temperature is not part of this. So parts per million equals 0.0043 divided by 100 times 10 to the 6th. Again, make sure that you're using things properly on your calculator with parentheses so that you don't get wrong answers. And when I solve this problem, I get parts per million equals 43. So I just want to let you know, if I divide 0.0043 by 100, you should get, for this part, 4.3 times 10 to the negative 5th. So you can double check that you're doing it on your calculator, and then you're going to multiply that by 10 to the 6th, and then you get this answer. Okay. This next formula is on your reference table. We've used it before, percent by mass. So it's percent mass basically equals part over whole times 100. And this is our part, obviously, in grams over our whole in grams, which is why it's called percent mass, because mass is measured in grams. So what is the percent mass? So we don't know percent mass of sodium hydroxide if 2.5 grams of NaOH, so that's our part, is 2.5 grams, and our whole is 50 grams. No, 2.5 grams of NaOH is added to 50 grams of water. So our whole is going to be 2.5 plus 50. That's the whole thing, which is going to equal 52.5 grams. So our percent mass is equal to 2.5 over 52.5 times 100. And when you divide 2.5 by 52.5, you should get a long number, 0.0476, yada, 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 times 100 is going to give you 4.76%. And that's NaOH. So the substance is 4.76% NaOH. Now, percent by volume is exactly the same thing, except for its percent volume. This formula is not on your reference table, except for it's usually the part in milliliters, could be liters, over the whole in milliliters or liters times 100, because it's percent volume, and volume is measured in milliliters or liters. So we're finding percent volume. What is the percent volume of alcohol if 50 mils of ethanol, so our part is 50 mils, is diluted with water to form a total volume. This time they gave us the total, 300. So our whole is 300 milliliters. So percent volume equals 50 divided by 300 times 100. And you come out with 16.66 repeating, make that 67% ethanol. And that's our answer. So when you divide 50 by 300, you should get 0.666667 times 100, and that's why we got the answer that we did. And that's it. You'll have time to play with these types of problems tomorrow and Monday in class. Look for another recording over the weekend that you need to watch from Monday's class. Have a great weekend. Any questions, please message me on Schoology.